going to go through the slides, and we'll first talk about Echolink. I think everybody knows what Echolink is. Echolink has been around for a long time. It's free. It's not open source, meaning that the code that it's written in is proprietary. You don't have access to that. So therefore, you can't make any changes to it. It's very limited. It does what it does, and that's it. You can't do anything extended from that. It has fairly low audio quality because it uses a GSM codec, and it's half duplex, meaning you can only talk in one direction at a time with it. It's relatively easy to use. It has probably the biggest user base of any VoIP system in ham radio. Because it's free, people get it, they put it on their computer. And if anybody's ever used Echolink, you can go into the user lists on there, and there really are a tremendous number of people on there. They're not always on, but they're listed in the list. It's stable but stale is what I have on here, meaning that it hasn't really changed in probably about 15 or 20 years. It's been around for a long time. And it's really a poor choice for repeater or computer linking. Some people do use Echolink to link repeaters, but it's really not a very good way to do it. So that's one VoIP that we have. The other that you've probably heard about is IRLP, Internet Radio Linking Protocol, and that came out after Echolink. It uses a better codec. It's still only half duplex, and again, it's not open source.
You might want to explain codecs. People might not understand.
Okay, a codec is a device that changes your voice to a digital and digital back to what you hear. So it's that relationship. And there's different codecs that operate differently and do it better and worse. A conversion of your voice to digital and then back again. IRLP has probably the smaller user base of any of the VoIPs. They wanted to only be radio originated. And what I mean by that is Echolink is usually only computer originated most of the time. In other words, if somebody's sitting in front of their computer with a microphone on their computer and a speaker on their computer. IRLP, on the other hand, is strictly radio. You still need to have the interface to go out over the internet, but the concept of IRLP is they don't want you to use a computer. People do, but they really don't want you to. The other problem with IRLP, and this also goes back to Echolink, is you really can only talk to one person at a time. You can only connect to one other node. You're a node, you connect to another node. With either of those protocols, you can only do one at a time. Now, there are ways to connect a group of people together, but it's nowhere as easy as Allstar is. Okay, now we'll talk a little bit about Allstar. It's fully open source, meaning the source code that runs it is available for anybody to look at, change, modify, or do whatever they want with it. And most people wouldn't know what to do with it, but it's there if you want to. So it's fully open source and changeable. That's the real beauty of it. And that's why we're able to make new versions of it on the internet. It has excellent audio quality. It's full duplex, meaning if you had a repeater, it's full duplex. If you had the same, if you had the same full duplex at either end, it would be like talking on the telephone. Most people, when you have a handheld, that's half duplex. But if you had at both ends, if you had a full duplex, in other words, you could talk and listen at the same time, then Allstar would allow you to talk just like you're talking on the telephone. It has an unlimited choice of codecs, which is what I described as the device that converts your voice to digital and digital back to what you hear. Whereas the other modes, it's much more limited. Or like in Echolink, you have no choice. It has a little bit smaller user base than Echolink, but it's growing. It's growing substantially. We don't care if it's radio, phone, computer originated. We do all of that. You can Allstar has the capability to call on the telephone, standard telephone. You're given a PIN number when you register with Allstar, and you can enter your PIN number and what node you want to connect to, and on a telephone anywhere, you can talk out over the radio. And if you wanted to do it from the computer, there's many ways to do it from the computer, and of course you can always do it from the radio. Very low cost. We'll go through that later. And there are bridges to Echolink and also IRLP and Allstar. So you're not limited to just Allstar if you're on Allstar. Every Allstar node can also do Echolink if you wanted to connect in Echolink to it. Okay, there's other formats out there, and I won't go into them to any great detail. Things like Skype. I mean, people use Skype to control their radios remotely. There's the wire system, and D-Star has its own system. Again, I'm not going to go into any of those because they're completely different from what we're talking about. Just a little bit of history about Allstar. In 1999, a man called Mark Spencer started a Linux software company. And their company needed a way to connect their telephones. It was a fairly large company, not tremendously large, but they wanted to have a software to connect their telephones. So he wrote a PBX software called Asterisk. And Asterisk is the basis of Allstar. It's a phone PBX, which means a program that will allow you to connect many phones together through, in different offices. In other words, if I had 100 people here, and I had 100 people down in Cape May, we could connect through the internet like we were in the same place. And that's the way that software works. So that was carried forward to radio by Jim Dixon and Steve Rogers. In about the mid-2000s. Allstar started about 2005, 2006. And that's when the first software was written. And it's written on top of Asterisk. In other words, Asterisk allowed you to talk via the internet with phones. So what they did is added the capability to add radios to that on top of it. Some of the features of Asterisk, it's a Linux operating system that's very well supported. It's fully open source, which I've said before, very easy to modify the code, extend the code. It is very easy to install and maintain, and we'll go through that a little bit later. Extremely low power consumption. We use the Raspberry Pi, it draws about 4 watts. So I mean, it's something you can just leave on all the time, and it draws less than a small LED light bulb. Has excellent voice quality, and it's great for people that have restrictions on antennas, because you can talk to the world with a radio without actually having any antennas other than the antenna that's on your local node in your radio, which could be right inside of your house. It doesn't even have to be outside. So if you were like in a retirement home, you could use Allstar to communicate around the world. You could use Echolink also, but this is more radio because you're actually using a real radio as opposed to sitting in front of a computer, and it's portable. Portable within your own home or around your own home. One of the big features of Allstar is any number of nodes can be connected together. So if you and 10 of your buddies wanted to make your own network, you could do that just by connecting together. You have to decide who's going to be connected to each other. You could all connect to one person, or A could be connected to B to C to D to E. It doesn't matter how you connect, but you would all be connected together. And you have that capability with Allstar. On a single IP address, which most people have, just a single IP address for their computer, and this is a big difference also, with Echolink and IRLP, you can only have one node per public IP address. So most people can only have one node at a residential location. With Allstar, it's unlimited. You could have as many servers and nodes as you wanted on a single IP address. When I say unlimited, I mean a reasonable number. I mean, you could have 100 if you wanted them, but that would be crazy.
I agree.
Right. Allstar was actually written originally as a repeater controller. And we don't always use it that way, but it's an excellent repeater controller. So for less than $100, you can have a very, very nice repeater controller. And most repeater controllers are $500 to $1,000 easy. And it's hard to add ports. The flexibility you have with Allstar is that every board could be a port, and you can add as many as you want, and they're connected together via local internet wherever you are. So it's very expandable and much less expensive than using a commercial controller. And as I mentioned before, you have connections to phone. You can go out over phone, or you can come in over phone if you want to. Another thing that's very nice about Allstar, I have here no political problems. You mentioned that about your club. Because it's open source. So there's nobody that controls it really. I mean, it's open to whatever anybody wants to do with it. IRLP is controlled by one person. Echolink is controlled by one person. At least I think it still is. I think it was, his last name was Taylor. I don't know, it's not the same Taylor that does Whisper, I don't think. Is John Taylor? Is that the name?
Yeah, I don't think it's the same guy.
Right. But in any event, when you have only one person controlling it, it becomes very political. They tend to demand how it's going to be used and how you're going to use it. Allstar doesn't have that demand. You can do anything you want with it. And in fact, Allstar is used commercially outside of amateur radio. I mean, it has any radio communications that would have use in it. It also is no single point of failure because everybody connects directly to the other person. They don't need to go through any server or anything like that. So it's whatever the internet connection between you and the other person is, that's what you're using. And you can build the systems the way you want to. There's no restriction on that. Just a little bit about codecs. These are three of the more popular Allstar codecs. We have ULAW, which is a lossless codec. There's no compression whatsoever. And when it's lossless, it requires more bandwidth, obviously, but it sounds better also. So the ULAW would have excellent audio quality. We typically use G726, which is the ULAW 64 kilohertz, the G726 is 48. So it's a little bit less bandwidth that you need, and it has very good quality. So there's really no reason to use ULAW, although some people want absolutely excellent, so they do use it. Your systems negotiate this. You can either allow or not allow certain codecs to come into your system. So somebody can connect to you with one codec, and you can connect to another person with a different one, and the conversion takes place in your system between the two. GSM is the worst. That's what Echolink uses. We have that capability if you wanted to use it. If you had a terrible bandwidth circuit and you wanted to get through, you could use GSM. And ILBC is Internet Low Bandwidth Codec. That's what Skype uses. And Skype has pretty good audio quality. A lot of people can't tell the difference between ILBC and G726. It's very close in quality, but it requires 1/3 of the bandwidth of G726. So we use it for mobile nodes a lot because it cuts down on your bandwidth usage with your provider. This is a typical simplex node. You see there you have your radio, it's connected, your handheld is talking to your node transceiver, and then we have a thing called a USB interface, which basically what that does is that's the the codecs. That's what converts digital to, the audio to digital and the digital back to audio. And that's connected to the Raspberry Pi, which is then connected to the internet. So that's the complete system. What you see there is probably about 10 times bigger than it actually is. It's very small. And I'll show you this hardware back there a little later. Okay, if you had a repeater, it doesn't get much more complicated. You still use the same USB interface. You have a separate receiver and transmitter, a duplexer, and an antenna. So now what you're doing is since Allstar is full duplex, you're allowing it to transmit and receive at the same time. And this is what it would look like if you were talking between two repeaters, how you would connect two repeaters together on the internet. Very easy to do. Tony's done it, so you know it's not easy. Yeah. I talked a little bit about how you would connect to different places. Let's just say this is the hub, which is the central place, and we have nodes 1 through 6 connected to the hub. But we also have node 7 connected to it, which is connected to another hub, B, and that B is connected to node 8, 9, 10, and 11, and 9 is connected to 12, 13, and 14. So that just shows you that, you can get very complicated, but all these nodes are hearing what everybody else is saying. They're all connected to each other. Now, if node 12 tried to connect to node 6, it would get rejected because it's a loop. He's already connected through this path here. He wouldn't be allowed to do that path. And Echo Link, if the hub supports Echo Link, would come in directly like that. That doesn't really apply to today. Some of these slides are a little bit old because we started out with a BeagleBone Black, which was a small board computer back in 2013. And at that time, there was no Raspberry Pi. It was the old Raspberry Pi, the Raspberry Pi B. And that would not work with Allstar. So we had to use the BeagleBone Black, and that was the first small board that we put Allstar on. And it started in early 2014. And with the first Raspberry Pi, and that's when I said we weren't able to get that to work. It just didn't have enough horsepower to do it. So we went to the BeagleBone Black, and I worked on it in the spring of 2014. We moved to the BeagleBone Black. We had success in the project, and at that time I teamed up with a gentleman, Dave, KB4FXC. And Dave and I are really the people that are in this project at this point. We had another hand, Chris, W0A&M, who was doing the weather scripts and some of the scripting, but he's kind of dropped out of the project, so it's really just Dave and I now. And our first release was in June 2014 for the BeagleBone Black. And we had a second release in October 2014 for the BeagleBone Black. And then and that's the BeagleBone Black. This is the USB interface that goes to the radio. That's the power supply. So that's not very big. That's the USB, that's a typical USB interface that you would buy and modify yourself, and we'll talk about that a little bit more later. And this is the Raspberry Pi. Doesn't look a lot different than the BeagleBone Black. It has 4 USB ports instead of 1. It's a more powerful board, there's a lot of other differences, but basically that's the major ones. This is and this is back on the back table. This is a transceiver that I built. This is a transceiver chip. It's built in a little tin can. This is the RF filtering here. But this is a little 1-watt transceiver. So this becomes a complete radio to use with Allstar if you wanted to do that. You can buy these chips for about $10. There's another example there. That's what it looks like outside. I actually have two of these back there that are set up as a repeater. They're actually a repeater. That's what it looks like, and that's on the back table. This is the receiver and transmitter, the USB interface. This is the computer, which in this case is the Beagle Black, I believe. And duplexer is here, mobile duplexer. I have a USB hub because I have the programming cable plugged into it. Oops, I went too far there. I have the programming cable plugged into it that you use to program this with. And I also have a 32 gig USB stick plugged in there for no particular reason, but you can plug anything you want that's USB into any of these boards, even a hard drive if you wanted to. This is a radio that we typically modify. It's a Bofang 888. They cost about $12 on Amazon. Pretty easy to modify for most people if you've done any soldering. But you don't have to take it apart and bring the cable out for Allstar. But for $12 plus the USB interfaces, which are $3. And again, they require modification, so you're going to have to do some bench work for this. $12, $3, $29.95 at Micro Center for a Raspberry Pi, which they're normally $35. But if you go in store at Micro Center, which Micro Center closest to here, I guess, is up in Philly, they're $29.95. Power supply is about $6 for the Raspberry Pi. The case is about maybe $6, $8. I mean, you can put a whole node together for way less than $100 if you build it yourself. Now, the commercial, this box here, the commercial USB fob is about $70. So if you didn't want to modify, you can buy that. And you can connect it up to your radio that you currently have. Most radios will work with this. Depends on what you have, but most will work with it. Okay, this is the modified Bofang used with the commercial USB fob that goes into the USB hub in this case, because this is using a Beagle Bone Black, so it only has one USB port. So in this case, we use the USB hub, and I have the programming cable plugged in here for the 888. The 888 uses a standard microphone programming cable, like you would use with any Kenwood. Any Kenwood programming cable will work with a Bofang, and you use Chirp software directly with it. This is the power supply for the 888. It runs on 5 volts, and you just have to put a little. This is the mobile battery pack, which the one that you buy runs converts 12 volts to 4 or 5 volts for the 888. It's not very good quality at all. We just buy it because it has the case, and then we open it up and put our own little power supply in there and run it from a wallboard, 5-volt wallboard. That's what it looks like when it's closed up. This was an early example of going mobile with a node. It was just kind of thrown together. This is a cradle point router, which was talking to Verizon through the cell system. And that's connected up to the Beagle Bone Black. This is just a 12 volt to 120 volt inverter. And this is in the back of my car. And there's a power strip. And, I'm driving around with a mobile node. That was like maybe a year or so ago, or more than a year ago, I guess, that we experimented with that. And it worked great. I mean, that's one thing you can do with this, is you can go mobile with it anywhere if you use your cell system to do it. Another picture of the cradle point router. Now, this cradle point router is talking to the cell system. It has Wi-Fi, but we're not using Wi-Fi. We're directly connecting to it with Ethernet here. And that goes into the BeagleBone Black, to the USB fob, to the node radio. So this is a complete system. This is the box that talks to the cell system. This is just the router here. And so you would have a handheld talking, you would have a handheld that you would have, or any radio, talking to this node radio. And then go out over the internet. Now this is a little bit more, I have this back here also you can look at. This is a portable node that was dated after that one. It's built into a Harbor Freight box you can buy for about $15 at Harbor Freight. Everything is in here except for the power supply in this case, which is this battery. It runs on 12 volts. It has a screen here. It has a keyboard, which isn't shown here, a little keyboard, you'll see it back there. The 888 is here, the Raspberry Pi, and it's a complete node you can carry, a portable node you can carry around. And the antenna for the 888 comes out to a bulkhead BNC that you can put an antenna on out here. This was at field day this year. I had it out there and back on my car, there's the keyboard there. Monitor, and I had it running from solar power. There's actually a battery behind this panel. This is a charge controller. So the solar panels were charging the battery, and the whole thing was running from that. This is a little bit more, this is a second generation of that. Again, the Raspberry Pi. This is the power supply, the 888 transceiver, which comes directly out with the antenna here. And as you'll see in the next shot, I brought all the connectors outside. So I use all power poles for everything. So there's power pole, this is HDMI video, Ethernet, and USB. And these go inside to the Raspberry Pi. And this is how we set this up. We did this today here. When you take a portable node out, you don't know what the Wi-Fi is wherever you are, so you have to connect to the Wi-Fi. So what we do is, and there's no way to do that unless you have to plug an HDMI monitor into here. The first portable node that I showed you had an HDMI monitor built in and a keyboard. Well, that monitor cost about $60, the keyboard costs about $15. So if you're cheap, which most hands are, this is another method to do it. We use an inexpensive portable router. We plug it into the Ethernet here, and you get the power from USB. You take your cell phone or your computer or your tablet, and you connect wirelessly to here. This is an access point. This Zytel is an access point. You connect to it, and then you connect to the Raspberry Pi internally, and you run the wireless setup. Tell the Raspberry Pi where to connect Wi-Fi. It could be your phone, it could be like here, the local Wi-Fi or whatever. Once you're done doing that, and once it's connected, then you can disconnect all of this, and then this portable node is connected to wherever you're located. The other method, of course, as I said, is to use an HDMI monitor and a keyboard. Either it's your choice. You can do it either way. And a lot of times, if you have a portable node, you're going to use your phone hotspot, your smartphone hotspot. So once you set it up, it's done. You don't have to do this every time. You can carry it anywhere. As soon as you turn it on and you turn your hotspot on your phone on, it's connected to it. So you could go out in the car and drive all the way across the country and be on Allstar, through your phone hotspot.
Unless you're AT&T.
What's that?
Unless you're AT&T.
Well, yeah, there is Verizon works really well. Freedom Pop, I don't know if anybody's heard of Freedom Pop, but that's a free service that gives you up to 1 gigabyte a month free that you can apply for, and that we know people that use that, and that does work. Modifying the sound fob. Remember that picture I showed you of the sound fob earlier? A sound fob is really just a device, commercial device, that allows you to plug it into a USB port on a computer and connect headphones and a microphone. It has a headphone jack and a microphone jack. And that's these two jacks over here on this end, over here. So what we do is we open that up, and we need to get two wires on the two pins of the surface mount chip. Now it looks really complicated, but once you've done it a few times, it really isn't, and it really goes very quickly. This is called wire wrap wire, and it's small enough that it fits underneath these pins. So what, you can't probably see it back there, but this wire here runs all the way through all these pins, and it's soldered to the last pin over here. So you strip the wire back, a very small amount, you run it through here, you bend the wire up over this pin, and you just tack solder it on there very quickly. Very easy to do with magnification and a small iron. The idea of putting it underneath these pins, it becomes a strain relief for the wire. So what this does is you have microphone in, it's the red connector here, and speaker out is the green connector. They go to your radio. So the microphone in ends up being the receiver output of your radio, and the speaker out goes to the microphone input of your radio. Through a little bit of interfacing, not a tremendous amount. One of these wires is push to talk to your radio, and the other wire is what we call COS, carrier operated squelch. That tells Allstar when somebody is transmitting into your radio. So that's the whole modification right there. I mean, minus a few extra parts beyond that, but they're easy to build. This is the hardest part. And these fobs cost about $3. You can even get them for about $2 if you buy them in quantity. So it's very inexpensive to do. This is another fob that I modified, and you remember those two blue wires from the other side. They come up, they're soldered onto the pins here, and then they're soldered onto bigger wires. This is push to talk, the red, and the white is COS, going over to the radio connector. And then we pick up the RX audio, the TX audio, and the ground. So it's 5 wires that go back to your radio. And then this is the USB connector here. That's the other side to show you. You have the green connector, the red connector. Some people take these connectors out. I say don't do it because these boards are very flaky. And if you fool around with them too much, you're going to pull up lands and really screw them up. So I just solder right onto the connector here where the jacks are directly. So there you go. That's a complete modification of a sound fob. And the extra parts you need at the other end, well, I thought I had that picture, maybe I do later, would go in the connector, in the DB connector that would go to your radio. This again is on the back table. You don't have to have a radio. You could build what's called a radioless node. And what that is it's one of those USB fobs that we just talked about. It's in this box, and a speaker and a microphone. You don't need the radio. You have the audio going out. You have the audio going in. So it's a neat way to do it without a radio. The downside of it is, you're limited to wherever that is. You can't walk around with it. It's not wireless. It would be a pretty good idea in the car. If you had a portable node in the car, you could use a wireless node. Again, it wouldn't allow you to leave your car with a radio, but if you just wanted it in your car, like your normal mobile radio would be, it would work fine. We have to talk about fusion, right? There we go. You see this thing here? You asked this question, I think, about being on FM. Where this says fix, and FM, that's locked to FM.
I'm sorry. Excuse us.
Okay. And there's a connector on the back of the fusion repeater. There's a 15-pin DIN connector on the back. You can jumper wires on there to force it into this mode. So nobody can mess with the connector, the push buttons on the front. You can't change it. And that's what I usually do for people that just want to run FM. What does it look like inside? If nobody's ever seen the inside of a fusion repeater, this is it. This is my modification down here. What I do is I cut the wire between the receiver. This is the receiver, this is the transmitter. And all these are is FTM 400s modified and stuck in there as a repeater. They're mobile radios. And that's why they blow up all the time in repeater use, but that's another story.
Non-duty cycle.
Yeah. The power supply is underneath, and what I do is I cut the wire between the receiver and the transmitter, this wire here, and I have a little board here, and I bring out the wires for Allstar from there. And it works pretty well.
You don't do it off the back connector now?
The back connector doesn't work.
Really?
Now,
I was going to tell these other repeater groups that have the fusions running, I was going to say, it's pretty simple. We'll just make up a connector and plug into the back and you're on Allstar.
It didn't work on the non-X model. I don't know if on the X model they may have improved it, but I'm not sure. I think people are still doing it this way. It's not hard to do this.
No, it's really not, but it's an easier sell than just say, I can wire it up and give it to you.
Right, exactly. Okay. How do you get on Allstar? Well, the first thing you do is you go to Allstar link, and I have a slide with this link on it, so you can write it down. You go to allstarlink.org, and you register. Once you register, and they determine that you are a ham, it's kind of like Echolink. They have to determine that you're a ham radio operator. You will be registered at the site. Now, at that point, you don't have a node number yet. But once you get registered, you can use what's called the web transceiver, which allows you to, on the internet, talk out over Allstar. It's not great, but it works. It's kind of like Echolink, a little bit better quality. It's similar to that.
Hey, Doug?
Yes.
Who actually does the verifications? I picture you sitting there not handing out
Not
notes.
me, no.
Who
no.
does that? I mean,
I guess somebody looks it up out on the West Coast.
I saw a note saying also that we're going to verify your call signs automatically now going in or something.
Yeah, they could do that too. Yeah, certainly they could go to a database.
But the nice thing about it is, you guys, it's very simple to do this. And the thing is, you request a node, and later that night or the next day, it's there.
Right.
Everybody should have one.
Yeah, it doesn't take more than sometimes even a few hours to get a node number. But there's no reason to get a node number immediately. I mean, you can just register and get used to it, and then decide you want to have a node or not have a node. That's up to you. And not everybody needs to have a node. I mean, Tony has a repeater that's connected, that's a node, and you can talk through that. The downside is that if you had your own node, you could connect where you wanted, when you wanted. With a repeater, Tony's going to want it to be connected to certain places at certain times and not have people connecting everything to everything. The problem with Allstar is you can connect too much stuff up because there's no limit. And we have some hubs that have hundreds and hundreds of connections on them. And every once in a while, one accidentally gets connected to my hub up in Philadelphia, and it goes crazy. We have to disconnect
the wind system.
Yeah, right.
Yeah, you guys are pretty big in your own right too.
Right. So if you go to Allstar Link, you can see here that you have this is once you register a node. You can then look at the nodes. You can set up your server, et cetera, et cetera. And I'm not going to go into a lot of detail on that. But there is lists out there of all the nodes, and there's what we call a bubble map, which shows the connections of nodes to other nodes, so you can get an idea of the topography of how things are connected. Just a little bit better picture of that. This is the web transceiver. So you would actually go in here and type in the node number and say connect, and it would connect to that node, and it would show you what nodes are connected to that node. And you would talk through your computer speaker and microphone. I don't recommend this on a long-term basis, but it's there if you need it. That's a little bit better picture of the connection block. Okay, I wrote a program called LS Nodes for individual nodes that gives you an idea of who you're connected to. And what it does is it gives you this kind of a printout. In this case, this was all the nodes that were connected. This is a small list for my hub. I guess I took this at an off time. But it shows you the nodes that are connected. It shows you how they're connected down here, and this shows you the status of your Allstar. And a lot of these things have to do with the repeater status of your Allstar. So if you're not using it as a repeater, a lot of them are meaningless. It's a little bit longer list of connections. It's a little bigger list. So what this does is it shows you the node number, the call associated with that, the description, which is usually the frequency they're on, whether they're simplex or duplex, and their location. And at this time, you know, I had Vineland, Woodbridge, California, Naples, Florida, Ray over in Petersburg, New Jersey. These are some of my nodes. Seaville, Smithville, Fort Myers, Florida. I mean, and this is like maybe 1/3 of the length of my list now on the hub. This is an old list. This is the bubble map I talked about. And this is an old bubble map. It's actually been improved now, so you don't have these lines over lines. But, you know, this one's connected directly to the hub. But in this case, everyone here is connected directly to the hub except this guy. He's connected to this guy. He's connected to the hub in that particular case. Here, everybody's connected. Again, there's someone connected through somebody here. This is a very good way to determine how people are connected to you. Because otherwise, you don't know. I mean, there could be some guy you're talking to could be connected to 10 different people. That's probably an exaggeration, but that could happen. So you need to go to the bubble map to be able to see that. All right, I'll talk a little bit about the update, which is coming out next week, I hope. I keep hoping.
So do I.
Before Christmas. Hopefully we're going to have a little Christmas present here. The one big thing about the update, in the past you've had to burn a SD card and plug it into the Raspberry Pi. If there was an update, you had to burn another SD card and plug it into the Pi and do the setup again, all your setup again. What we've done is we have our own repository, which means all the software is stored out on a computer somewhere, and you do all the updates on your system. Once you have to do the SD card one time, but after that, all the updates are done online. So you don't have to burn any new SD cards. There's going to be more updates, and they're going to be more often, because it's going to be much easier to do for you and us to do the updates. So that's like a really important thing. We also completely redesigned the setup, and now it uses all graphical setup. It's still in the command mode screen, but it's graphical as opposed to just text and letters on a black background. So it's a little bit nicer in that regard. We've created what's called an admin menu. So people that don't understand Linux and don't understand, you know, what to type in when it says, you know, your prompts there, what do you type in? We created an admin screen, and that admin screen will basically give you every option you need to set up the system and maintain the system. So basically, you don't have to go out to Linux at all. Now, there's a capability to go out, but you don't have to if you don't want to. Another big thing that most people won't probably, maybe not realize is there. We went to the high-resolution timer on Raspberry Pi. That's a pretty big thing, and that's probably almost as big as the number one thing, which is the online updates. PCs have a high-resolution timer. The Raspberry Pi does, but the code, the Allstar code, doesn't use the high-resolution timer normally. So we implemented using it, and that makes all the timing. And believe me, there's a lot of timing that goes on in Allstar, especially when you do codec conversions and things like that. It makes all that so much better. And it really does make a big improvement. We're also using the latest kernel, 4.4.32. Latest PHP 702. We completely reorganized the rpt.conf. I guess it's kind of a mess. So we reorganized it by topic. There's a help message for every item in there to give you an idea what it is.
Awesome.
It's going to be much easier to be able to see that. The wireless scripts are now installed by default, and we updated those also. This is it's actually different than this in the final rollout, but this is the admin screen. And one of the things that we did is you can change the root password, you can change the system name, you can change the wireless information, the wired information. There's a lot of, you can reboot the system from here, power down the system. You can go out to a shell script where you can actually put commands in, display all the version numbers of the current software, and just about everything you would ever do to maintain your system. You wouldn't really have to go out of here. Change the time zone, the host name, etc. So this will be added to and expanded in the future, but it really makes it easy. And the system will actually boot to that, when it boots up. Another big thing, and anybody that's used Allstar, to do the setup. You want to turn on pre-emphasis, turn off pre-emphasis, turn on RX boost, turn off RX boost. Then you got to go back out, you got to restart the system for it to take effect. All that now is immediate.
On the fly.
On the fly, everything. It's really neat the way it works. So you can go in, and while you're talking to somebody, you can be in the simple USB 2 menu, which is what this is, and you can toggle the PL filter, toggle the pre or de-emphasis, and immediately they're going to hear the difference while you're talking. The big thing about this is, and this is the P option in simple USB, shows you all your current parameters. The big thing about this is there's also a real-time display of what your COS and push-to-talk are doing. So one of the big things about setup is different radios have different COS outputs. One might go high with signal, one might go low with signal. So you don't know what it is. So all you have to do is set it, and this doesn't show the whole screen, but up top you would set the COS inverted or uninverted, and it would show up down here whether it's seeing it as a true or not, immediately. So that's a really nice feature.
I'd say that.
Okay, more updates in this version. It has Bluetooth. It's not really implemented beyond the fact that it's in the system, and we'll probably expand on that in the future. It does have an IRLP gateway built in, but not implemented.
Yeah.
The user would have to implement it.
What's the deal with that? Do the IRLP users get upset about?
We don't care.
Okay, fair enough.
Really, I mean, they can get pissed off if they want, but we don't care.
I don't know why it matters.
Right. And also there's a D-Star channel driver. But again, you'd have to implement that. And we'll have information on how to do that if you wanted to. I don't know why anybody would want to run D-Star anymore anyhow, but some people do. We cleaned up the Echolink code. The Echolink code had some bugs in it. Some of them pretty severe. And at times it would crash, so that should be straightened out. And then, of course, I said the real-time changes in the display. The LS nodes have been updated. There's been a tremendous number of bug fixes in the code and code improvements. The other thing is that a lot of people seem to have problems with modifying the USB files. And we're trying to make it easier for people to implement the interface between the radio and the Raspberry Pi. You can go out and buy that commercial box for $70, and it's plug and play. But a lot of people don't have the money or don't want to spend the money to do that. The cheapest interface out there is about $50. So as I mentioned, for $3 you can modify a sound file. The problem is that not everybody wants to solder wires onto a surface mount chip. I don't think it's that hard. and it's only a $3 board, so if you mess one or two up, get another one and try it again. But people just don't want to do that. So what we did is we came out with a way to do that with a nano board. And nano is our Arduino Nano, and I have it back there. I can show you what the board looks like. I don't know if I have any pictures here or not. But that allows you to do that interfacing without having to do any intricate soldering. And it's still like the nano board is like a $2 or $3 board. Yes?
I'm sorry, just back up for 1 second. When you say you cleaned up the Echolink code, I'm curious about that. How did you actually clean up Echolink's code?
Oh, well, I'm talking about the Echolink interface in Allstar.
Okay, so
not their code.
The Echolink.conf.
Yeah, right.
So
we need to be able to interface to Echolink.
One of the issues, and I probably shouldn't bring it up now for long things, but one of the issues I have in there is it doesn't announce nodes coming in on the Echolink side.
You may not have it turned on.
Well, that's at the ENA mode.
Right.
But I do have it on too. I think it's the actual number that's supposed to be on. I don't know, it doesn't seem to work right. There's a couple of issues with that, but go ahead and we'll talk later on.
All right, very good. So anyhow, the interface, we're going to be coming up with a lot of different methods to interface. And the whole idea is hams like to experiment, they like to build things. This is just another way to interface using this nano board. It's not something you have to do. We're not going to drop support for using the USB fob as it is. And in fact, just in the last week, I found new fobs. And the other problem is these fobs. Where the picture I showed you with a chip and wire soldered onto it.
Yeah.
This stuff is all made in China. You can't get it from the U.S. You got to buy from China. So what happens is that they put a blob over that, so you can't solder to it. And a lot of the chips you get now, a lot of the USB fobs you get, cheap ones, you can't modify because of that blob on it. So that's another reason why we came out with this nano project, to be able to do the GPIO interface without having to use the USB fobs. But I just found new fobs that they don't even put any case on. You'll have to see a picture of it. I don't think I have a picture here, and I don't have one yet. I just ordered 4 of them, but they're bare. They're totally open, no case. They don't even have the metal shell around the USB connector. They just have the circuit board with the pins on it, so you push it in to the USB jack. That's it.
Winner.
And you can see right away that it's not potted. So it's pretty easy to modify. And they're $3, $2.90 I think. I got 4 of them for. So they're not very expensive. Just to go real quickly, new commands that will be in this code. They were actually in the last code, but only in the beta version of the last code. We added an RX timeout. I don't know if anybody's ever experienced it. Somebody's node locks up, and you're not there to disconnect it. It'll just time out the whole system. We implemented a timeout so that if your radio locks up the system, you can set the amount of time that it will clear. And it's defaulted to 5 minutes. I recommend people change it to like 3 minutes or maybe a little bit over 3 minutes, because that's a timeout on repeaters. And you would never talk more than 3 minutes, hopefully, in any one transmission. So what happens is if your node locks up and it goes over that time, it'll drop the network and it won't tie anything else up. There's another one called RxCOS flat, and what that is another problem that can occur is if your squelch is like sitting there opening and closing real fast due to noise, that will register as a timeout after a period of time, and that's what that command is for. A lot of people, the messages that come through, they want to be able to turn them down versus the voice of the person they're talking to. You can do that with non-dB command, and it's in decibels, gain change. Duck dB, what that is it changes the level of the messages when somebody's talking versus when they're not talking, so that you can lower the level when somebody's talking. The messages are still there, but they're in the background. And we changed the TX timeout so that it was consistent with RX timeout. It was formerly TO timeout in the old code. New scripts, I've gone through all that. We took the source code out of the package because it takes a lot of space. Most people don't care about the source code. The source code will be available for download as a package if you want it. But it means that when you get this update, it's going to be smaller than any image you've had before. And you're going to say, well, how can it be better and be smaller? It's a lot of stuff is taken out of there that's not normally used. But you can download it if you want to. Okay, I think this is the last slide. Just the future things that we're going to do. And again, these will be downloadable directly over the internet. You won't have to burn a new SD card to do this. We're going to completely rewrite the sound system. The current sound system in Allstar is written in OSS, which is totally obsolete in Linux at this point. Everybody uses ALSA. So it's going to be rewritten in ALSA, and it's going to use I/O pipe to talk to the audio devices, which is really a big thing, because what it will allow you to do is to take the audio and process it externally from Allstar. You can filter it, you can equalize it, you can do anything you want with it externally, and then send it out over the radio. So that's going to be a big thing when that happens. And that will be a merging of simple USB and USB radio, so that you will be able to, the DSP functions will work again, and you'll be able to not have to use COS eventually. There's going to be a detailed update of AppRPT.C. Right now, it's really what we call spaghetti code. When you have more than one person developing a system, and they don't coordinate with each other, and they don't put any comments in the code, it's very, very difficult to work with, and that's the way the code is. And we're going to try to straighten that out. And many of the items that are currently in the code will be taken out, because they're redundant to things that are in the system. It doesn't make any sense to have certain things in the code that are already in Linux. It's just redundant and not necessary. Another big thing, and the problem with Allstar is that when you bring a node up, it immediately downloads the node list to your local box. But all those thousands of people out there that have nodes don't know about you until they do an update, and that could take up to 10 minutes. So the problem is people want to immediately be able to do something, especially if they're a portable node, because they may not be on the air very long. The guy might get in his car, come out of a store, get in his car, and have a 10-minute drive home, and he wouldn't be able to connect to anybody because of the time delay. We're going to implement a DNS node lookup, so that instead of this download from some master server, it'll be a DNS lookup, just like you'd look up an IP address on the internet, and it'll be that quick. So there won't be the delay. The maximum delay maybe be 20 or 30 seconds until all the databases update. So it's really going to be a big change, and hopefully that'll work out for the people that have portable nodes. And we're always looking for your input and suggestions for any changes to the code. Can't satisfy everyone and every little thing they want, but if there's something that you think would be worthwhile in the code, certainly suggest it to us. There's two URLs that are important. One is hamvoip.org. That's where you get all this information, all the how-tos. Everything that's built over there is documented on there, and you can look it up and build it yourself or see how it's done and get ideas. That's hamvoip. That's where you download the software. That's where you can join the forum. We have a forum that you can join if you have any questions. And the other one, as I mentioned, is allstarlink.org, and that's where you actually register your node and get the web transceiver. That's really the only two you need. My email address is on there, and my Allstar node is the Philadelphia hub. is node 27225, and my Echo link is WA3DSP-L.
All right, I'll call you.
That's about it. Any questions?